Okay, so we are looking at Chem Live question 13.16. In this question, the giveaway is going to be sodium carbonate, but there'll be a .xH2O somewhere in the question. And because of that, then this cannot be a primary standard, because on a very hot day, there might be less water of crystallization attached, and on a very cool day, there may be more. So because of that, we can't weigh it out to make a solution of accurately known concentration. So it's not a primary standard. So we always start with our data table. So we have attic and basement. We are going to be looking for what goes in the basement is going to be something that's measured out with a pipette. So we are going to be looking for a whole number. So if we read across our question, in terms of a whole number for the titration data, it says 25 centimeters cubed of this solution was titrated against 0.11 molar HCl. So in our basement, it's going to be the Na2CO3 is what we're titrating, not the .xH2O, because that's just water, it's not a base. So we fill in our data table, so we're going to have 25 centimeters cubed of this. From our equation, the ratio for the sodium carbonate is 1. This means this is the HCl. The ratio from the equation is 2. We found out that we have 0.11 big M in there. We're now looking for a titration value, and we find that here. So we have 22.8 centimeters cubed. This should be our question mark, but just to check, we have a look at where it says the calculate, and we're calculating the Na2CO3, so that is our question mark. So just a reminder, in terms of our maths, we do our first principles to get us the big M value for, in this case, the sodium carbonate. We start with the moles of our acid, and that is going to, this is going to be our weigh-in when we get there. So we always start with how many moles there are in a litre. When we go down our W, we divide. So we're now dividing by 1,000 to find out what's in 1 centimetre cubed. When we go up, it's always a multiplication, and that's going to be against our HCl's titer volume. When we get to the flat part, we apply our ratio, and that gives us the moles of either reagent at the end point. So once we have the moles of, in this case, the sodium carbonate, we're going to go down and we divide by its titer volume to find out how many moles are in 1 centimetre cubed. And then finally, to finish it off, we're multiplying by 1,000 to give us how many moles in 1,000 centimetres cubed of the sodium carbonate. We will be using our mass triangle at some point, and this has 2 extra pieces of maths. We have to work out the percentage of water and the value of X in XH2O. So what's the ratio of those? There will always be extra information in a question, so you need to read through it to figure out what that is. So if we read through the question up here, we have 3.55 grams, and that's made into 100 centimetres cubed. So personally, I would take the 3.55 in 500 centimetres cubed, and straight away I will bring that up to grams per litre. And the reason I am doing that is because I'm going to be using this number to compare against my titration data, and the titration value is always going to be in grams per 100 centimetres cubed. So we're going to take our weigh in, which is the 0.111 big M, and I always like to say what that means. So that is moles in 1,000 centimetres cubed. So we are at this point of our W up here. So our first step is we have to divide the 0.11 by 1,000. And when we do that, we are going to get 1.1 by 10 to the minus 4 moles in a centimetre cubed. If your calculator is not giving it as standard or scientific notation, then you write down whatever it is your calculator is giving you. So now we're at this little point in our W. Our next bit is to multiply by our titration value, which in this case is 28 centimetres cubed. So when we do that, we get 2.5 by 10 to the minus 3 moles, and that is in 22.8 centimetres cubed, and that is our titer volume. So we're up at this point. We're now going to apply our ratio. So the ratio is a 2:1. where the 2 is the 2.5 by 10 to the minus 3 moles. So I divide by 2, multiply by 1, and I end up with 1.25 by 10 to the minus 3 moles. And this now is going to be in my other titer volume, which is the 25 centimeters cubed. So here we've applied our ratio. So the next thing we're going to find out is how many moles are in 1 centimeter cubed. And to do that, we have to divide 1.25 by 10 to the minus 3 by our 25 centimeters cubed. When we do that, I get 5.01 by 10 to the minus 5 moles, and that's in 1 centimeter cubed. So I've gone to this point in my W. And then finally, to finish it off, we have to multiply by 1,000 to turn it into moles per litre and a big M value. And when we do that, we get 0.50016 big M. Now, if you go back and we have a look at our data table up here, we have 3 significant figures in our data table. So I will always use that as my answer. So these are the first 3 significant figures, and we always look at the number that comes next to decide what we do with the third significant figure. So in this case, that would be 0.0502 big M. Okay, so that's my first principles. The next thing, and to find big M, we now have to work out grams per litre. So it's going to be our moles, 0.0502 by our molar mass of sodium carbonate, Na2CO3, so 23 by 2, 12, 16 by 3. Add these all up together and we say 106. And the reason we're showing the working out, again, if I make a mistake and I say even though these numbers here are correct, but I write down 105, then I lose the marks for this. But if, no apologies, I would have what's called a slip. They would take away 1 from me. But if I was just to write over here 105 straight away and show nothing, then this would be worth 0 and my error would be carried forward. And as long as I made no more mistakes with my numbers, it should all work out fine. Okay, so I'll show your examiner everything. So we now multiply by 106, and when I do that, I get 5.32 grams in a litre. Now, if we go, I've always said, do your big M calculation, do your grams per litre, and then we have a read of our question to see what it is we have to do. So it is asking us to work out the percentage of water of crystallisation and this value of X. In a Leaving Cert question proper, they would possibly be ticks for maybe this part and this part as we go down through it, maybe for final answer, maybe for this, maybe for this. So it's very much depending on the question, but for us today and where we're at now, we are going to finish our piece of maths in terms of percentage water and in terms of the value of X. So this is how I set it up. We weighed out our extra info at the very beginning up here. We worked out that we had 7.1 grams in 1,000 centimeters cubed. So the whole thing that I weighed out was worth this. When we do our titration, the titration gives us the sodium carbonate by itself. So that's the 5.32 grams in a litre, and we find this by titration. The next bit that we have left then is how do we work out how much water is there, and that just becomes a subtraction. It becomes a subtraction of the 7.1, take away your 5.32, and when we are done, we will have 1.78 grams in a litre. Okay, so it's really important that you can kind of see everything. So this is whatever our total, what we weighed out at the beginning, includes the carbonate and the water. When we titrate, we find the carbonate alone, and the difference between them is the water. So if I'm looking for percent water, I am looking for the grams of water, and I'm going to put that over my total grams. And I'm going to multiply that by 100 over 1. So when I do that, I end up with 1.78 over 7.1 multiplied by 100 over 1, and that is going to give me 25.1%. Okay, so that's my percent water, so that will be part A in that question. If you can't annotate, then don't annotate, but as long as everything is kind of laid out linearly and your examiner can figure out what's going on, then that will be fine. So to finish the value of x, we have to do empirical formula. And empirical formula, when we did it, introduced it first, was just with elements, but now we're going to do it with compounds. So we write in our 2 compounds. So just to remind you, we find our moles and then we divide by the smallest number. So we have 5.32 grams for our sodium carbonate. I'm going to change the color of the pen. So we have 5.32 grams of sodium carbonate. We divide that by its molar mass, and when we do that, we are going to get 0.0502. And if you're clever, you will notice that we've just worked backwards from here to here. Okay, so for our water then, we are going to be dividing 1.78, and we have H2O, which is 1 by 2, and 16 is equal to 18. So we're going to be dividing this by 18. And when we do, we're going to get 0.0988. So when we look at the 2 numbers, this is the smallest number. So we divide everything by the smallest number. So 0.0502 divided by 0.0502. So 0.0988 divided by 0.0502 gives me a 1 is to 1.96, which is the same as saying 1 is to 2. So x in this case is equal to 2. Na2CO3.2H2O is how the formula would be written on the pot, and this would be your answer.